relative position of two planes. Either two planes are parallel or coincide, or they intersect along a straight line. So to know if they are parallel or coincide, if you have two planes, if you have A over A prime equal B over B prime equal C over C prime equal D over D prime, so they coincide. If you have A over A prime equal B over B prime equal C over C prime, but not equal D over D prime, so they have the same norm, it means they are parallel but not coincide. However, if you don't have this condition, they intersect along a line. So how to find the equation of the line of intersection? You can pick let z equal to m and solve for x and y for both, or you can pick x to be m for you solve for y and z, or you can pick y to be m and solve for x and z in terms of m. So let us take an example to understand. Study relative position of the two planes here. If you do here minus 6 over 2, 9 over minus 3, minus 6 over 2, and minus 12 over 4, all are equal to minus 3, so they coincide. For number 2, if you do minus 6 over 2, 9 over minus 3, minus 6 over 2, all they are equal, but minus 12 over 5 not equal, so parallel lines. Suppose here you have these two. Since minus 3 over 2 not equal 2 over minus 3, no need to continue, the planes intersect. So here I'm going to say let z is m. So you're going to get 2x minus 3y equal 4 minus 2m. Here minus 3x plus 2y equal minus 1 plus 6m. So here I want to cancel either x or y. So to cancel here, I multiply by x up by 3 and down by 2. So you're going to get this one. So 13, so minus 5y equal 10 plus 6m. So y will be in terms of m. And similarly, you cancel for x. So here you're going to get x equal minus 1 minus 14m. So the line is xyz. It has a directing vector of minus 14 over 5, minus 6 over 5, and 1. And you have one particular point, minus 1, minus 2, and 0. So this is the equation of intersecting between the two planes. هلا relative position of a line and the plane, either a line parallel to the plane or inside or intersect. So this is a parametric equation and this is a plane P. هلا how to find it? So how to find the intersection between a line and the plane? So you have the line, you have the plane, you replace xyz in the plane. Okay, when you replace it, you're going to have all in terms of t. If you have 0t equal to 0, infinitely many solution implies that L subset of the plane P. If you have 0t equal to a number not 0, it is impossible. So it means that L is parallel to P. And if you have t is a number, so they intersect at a point. So you replace t here and you get a point of intersection. So let us take an example. Find the relative position of this line. So here I replace x by 2 plus 2t, y by 1 plus 4t, and z by 2 minus 2t. You're going to get 0t equal to a number impossible, so it means they are parallel. Here, if you do this one, you're going to get 0t equal to 0, it please coincide. Here, if you do it, you're going to get t is minus 3. So replace here t by minus 3. You're going to get the point of intersection 2 minus 6 minus 4. 1 minus 12 is minus 11, and 2 plus 6 it is 8. هلا relative position of a line of two lines, either the lines are parallel or coincide, or they intersect or skew. Skew, it means they don't intersect. Okay, so what do you do? First of all, we're going to talk about parallel or coincide. If you have, for example, the parallel, yani v1 over u1 equal v2 over u2 equal v3 over u3, it means they are parallel or coincide. To know if they are parallel or coincide, you can pick any point here in the first line and check if this, you replace it here in xyz, and if you have the same t for all, it means the two lines are the same. Let us take example for the first two cases. Study the position of the following parametric equation. So here, if you do minus 6 over 3, minus 2 over 1, 4 over minus 2, all are equal minus 2. So they are parallel or coincide. So we pick a point here in the first line, 2 minus 1, 3. We're going to replace it here, 2 minus 1, 3. So we're going to calculate t prime in all. As you can see, t prime in all is the same. So it means that this point here, it's also in line L prime. So in that case, they coincide. If you take this one, You can see minus 6 over 3 and minus 2 over 1 and 4 over minus 2 equal minus 2. They are parallel or coincide. You can pick the point here, which is 2 minus 1, 3. You replace it here. So you can see that the t's that we have are not equal, are not the same. So they are not, so this point here that you have it in the first is not in the second. So it means they are parallel. Now we have either intersect or skew now. Hello, to know if they intersect or are skew, they don't intersect. So let us take this example. As you can see, v of L and v of L prime, if you do 3 over 3 and or minus 1 over 2, they are not equal. So either they are skew, they don't intersect, or intersect. To know, you have two methods. So you can equate here xy equal xy. You find t and t prime by two equation, two unknown. If you do it, you're going to get t is 1 and t prime is 2. You replace here t by 1 and here t prime by 2. If you have the same z, it means they intersect. So here you can see they have the same z, minus 1, minus 1. So if you replace here t by 1, you're going to get 5, minus 1, and minus 1. And if you replace it here, t prime by 2, you're going to get minus 1 plus 6 minus 5. And 1 minus 2 is minus 1. Minus 11 plus 10 is minus 1. Or you have another method. If two lines intersect, it means they form a plane, because two intersecting lines form a plane. So that's why we can do the box product. You know that line L is parallel to vector VL, line L prime parallel to vector L prime. You can do VL cross VL prime, which is a vector perpendicular to plane P. If vector V with A, and you pick a point A on L and a point B in L prime, for example, if VL cross VL prime scalar with AB is 0, it means that they belong to the same plane. So you can use this method, the method up, or you can use the method here. If it's equal to 0, they intersect. So here we pick point A here, which is 2, 1, 2, and point B on the other line, minus 1, 1, minus 11. V of L is 3 minus 2 minus 3. V of L prime is 3 minus 1, 5. We do AB dot VL cross VL prime. As you can see here, it's equal to 0, so they intersect in a point. And if you want to find the point of intersection, we need to do this method that we did up. Okay, you can equate 2, you find t and t prime, you replace it to get the common. Now we're going to continue here in the second example. So here you can see that 3 over 3 minus 1 over 2, they are skew or intersect. So if you get the first two, method 1, you can see t is 1 and t prime is 2. If you replace t is 1, you're going to get z is minus 1. If you replace t prime is 2 here, you're going to get another z. So they don't intersect, they are skew. Or you do this one, the one we talked about. If it's not 0, it means they are skew. Now, to finish, angle between two planes. If you have two planes, for example, let me take an example. If they ask you to find the angle between two planes, it's the same as finding the angle between their two normal. So it's np dot nq over norm of p times norm of q. Angle between two lines is the same as finding the angle between the two directing vectors. Angle between a line and a plane remains. Let me explain it. So suppose this is a line that intersects the plane here in this point. So suppose here the angle alpha, and this is the projection, the normal of the vector, which is n. So here alpha and beta, we know that alpha plus beta is pi over 2, so alpha is pi over 2 minus beta. If you want to do sine alpha, is sine pi over 2 minus beta, which is cosine beta. So sine alpha here, I want to find this angle, is nothing else than equal cosine beta, and sine alpha is what? Is opposite. This is sine alpha, which is cosine beta here, and we know that cosine beta is the angle between the normal and the directing vector of L. So it's np times v of t, normal of the vector p. This is the normal, and this is the directing vector of vector d over norm of p times v of t. So I want you to memorize this formula here.